A monochromatic source of light is operated at 500 watts with 80% efficiency. The number of photons emitted per second are 8 into 10 to the power 20. We are asked to find the wavelength of this light. So if you write down the energy emitted per second, per second, if I consider the source of light, per second the energy emitted is 500 joules. That is with an efficiency of 100, but the efficiency is 80. So out of 100 we are getting, let's say, 80. So the actual energy emitted will be 500 into 80 by 100. So how much is this? So this will be 400 joules. So we are just getting 400 joules of energy. Now, if I consider each photon, the energy will be hc by lambda. And if I multiply by the number of photons, I should get the total energy emitted from this source. Now this energy obviously is equal to 400 joules. So from here we need to get the value of lambda. So let's write down the values of Planck's constant and the speed of light. So the Planck's constant's value is given 6.63 into 10 to the power minus 34. C is 3 into 10 to the power 8 and divided by lambda. So into 8 into 10 to the power 20, and this is equal to 400. Okay, so we can take lambda to one side and then put all the numbers together. So lambda is equal to, so let's multiply the number 6.63 into 3. So how much would that be? That would be I think 19.89. So if you multiply, okay, into 8, and then let's look at the powers of 10. Minus 34 plus 8, that's minus 28, and minus 26, minus 26 plus 20, so that is 10 to the power minus 6. So divided by 400. Okay, so we need to write this in terms of nanometers. So we need to get that 10 to the power minus 9. 1 nanometer is 10 to the power minus 9. So what we can do is, you have 100 in the denominator. If I take it to the numerator, we have 10 to the power minus 8. And then if I multiply by 10 to the power minus 1, I'll get a nanometer. Then I'll have to multiply 19.89 by 10. So we can write it as 198.9 into, let's say, 8 by 4 is 2, and into 10 to the power minus 9. So that's a nanometer. So now what do we have? I think the answer looks like 398 nanometers. So this is 18. So 7. Yeah, so 397.8 nanometers, but roughly, so we can take it as 398. And again, if you are able to estimate it before getting the actual number, that's even better, because the answers are slightly apart.